Hey, this is Shashi. I am from PowerFlex product management team, and I focus on developing applications and workload solutions with PowerFlex. In today's session, I am going to talk about enterprise databases on containers, specifically with PowerFlex and VMware. So let's go through some of the specific data points as why enterprise databases on containers. So a recent study by Gartner predicts that by 2022, more than 75% of global organizations will be containerized. Again, this is very, very predominant for database deployments also, as database customers are looking for kind of flexibility and then also kind of speed and also some of the key benefits which they can get while deploying containers. And then also some of the other benefits, as you can see, is the startup for container-based deployments will be in the milliseconds. And then there are a lot of advantages with respect to cost, and then also with respect to the speed of the deployment. So, and then also for a lot of customers, again, there is always a question, especially for customers who have already invested and then have standardized on virtual infrastructure. There is always a question, should I do virtualization or should I do containers only? Or is there a benefit of deploying containers on top of virtual machines? So this question, again, the answer to that is definitely yes. There are a lot of benefits of deploying containers on top of virtual machines. Again, the specific, probably I will highlight one or two big reasons. One is the security, and then also the other specific reason is the isolation. So there are some specific benefits with respect to security and isolation, which you can get by deploying your containers on VM rather than deploying it on direct bare metal. So especially on a software-defined storage like PowerFlex, which I'm going to cover in the next couple of slides, you get the isolation and then also the consolidation benefits of running multiple container stacks within VM on the same PowerFlex infrastructure. So as I mentioned, let's go through some of the key power positions or key values of what is PowerFlex, and then also what are the key differentiations with PowerFlex. So PowerFlex, Dell EMC PowerFlex is a software-defined storage. And again, the three key tenets for this software-defined storage are harnessing the software, embrace the change, and deliver predictability. Harnessing the software is through the performance and scalability benefits, including fluidity. And then also the embracing change is with respect to the different kind of deployment architecture you supported, and then also the kind of different consumption models and then the platform support PowerFlex provides. And then also you can be sure of the workload execution predictability here. And then also it provides you end-to-end automation and orchestration capabilities. So why, again, the PowerFlex software-defined storage, again, if you want to go a little bit detail on this. So this is a software-defined storage known for its performance, scale, and resiliency. I talked about performance, how it can provide you that kind of extreme performance. It is due to the unique architecture PowerFlex provides. So PowerFlex architecture, you have like 3 or 4 nodes who are working, who are actually contributing to the I/O. Again, in the PowerFlex architecture, every node of the cluster is contributing with your I/O operations. Again, every single drive on that node is also contributing to the I/O operations. So this is one of the primary reason why you get this kind of millions of IOPS at sub-millisecond latency for any of these kind of enterprise critical applications. So the aggregated resources with respect to nodes and also the drives which contribute to every I/O operation provides you massive performance and also scalability benefits. When I say scalability, again, PowerFlex can be used with a very small footprint. You can start small and then grow big as needed. Again, you can start with like as few as 4 nodes, and then you can scale up to thousands of nodes without any impact to your performance or any latency implications. So the other key thing which is very critical for database administrators is, especially for database deployments, is the resiliency. And PowerFlex provides that 6 nines of availability. So when in a cluster, if for some reason, if there is a planned or unplanned outage, you don't have to, or an IT administrator or a DBA, you don't have to worry about the storage platform, because the PowerFlex will automatically heal on its own, and then it will do the rebalancing with the existing nodes. Similarly, once a node is online, again, it knows the node is online, and then automatically the IO operations are optimized, and then the storage rebalancing happens automatically in the background. So this is really a key benefit, especially for database administrators who are managing mission-critical applications like Oracle, SQL, and then also some NoSQL databases in financial and other industries, because they don't have to worry about the backend storage for the optimized performance. They can focus on their applications, and then also they can make sure that the day-to-day operations are running smoothly. With respect to PowerFlex, again, the other key benefit or the value add is the flexibility with respect to deployment architectures. So in PowerFlex, one of the key differentiation is the disaggregated or the two-layered architecture. Here, you can have compute and storage resources managed independently, and then also you can scale them based on your need. And also, PowerFlex supports if you need a hyper-converged architecture or a hyper-converged model, wherein you can have all your compute, storage, and networking resources on the same nodes. And there are also a lot of customers and then use cases where they start with a hyper-converged environment like a 4-node or 6-node configuration, and then you can, based on your need, you can add your compute resources to the same infrastructure. So you have all this kind of flexibility with PowerFlex, which is very critical for, again, databases and database administrators. And then also I want to highlight the other key differentiation with PowerFlex. Whatever is the kind of application, whether it is like a mission-critical databases or a throughput-intensive analytic application, or like a generic mixed workload or a virtualization or a virtual use cases, or a cloud-native or container-based applications, including AI, ML use cases, and then whatever be the orchestration, whether it is VMware Hypervisor or OpenShift or even a bare metal configuration, you can deploy your applications without any performance implications. So PowerFlex supports whether it is bare metal, virtual machine through hypervisors like VMware or Hyper-V, and then also containers on top of bare metal if required. So it provides you this kind of complete flexibility wherein you can confidently deploy different kind of application based on the needs. And then also PowerFlex supports some of the key features which is very much required for databases, such as native replication and inline compression, and including a lot of quality of services and also secure snapshots and others. So let us go through a little bit more detail about some of the reference architectures and validations which has been done with PowerFlex and VMware, again, especially on containers for enterprise databases. And I'm going to cover both traditional databases such as Oracle and SQL, including some of the work done with respect to NoSQL or modern databases like Cassandra and MongoDB. So as I mentioned, PowerFlex is an ideal platform for databases as well as containers because of the flexibility which I mentioned. It provides a complete flexible platform, and then also PowerFlex has an orchestration tool which is kind of capable of doing your end-to-end automation, and then also it dramatically shortens your complete life cycle by managing your system end-to-end, including networking, compute, and storage resources. And then also the flexible design, and then also the flexible models, which I explained, like two-layered architecture and the hyper-converged configuration, helps a lot with respect to databases. And then again, especially for containers, you have the flexibility again, depending on your need. You can deploy containers on top of virtualization if required, on VMs, or also on bare metal if required for specific use cases. And then there are also specific use cases where you can deploy some traditional databases like Oracle probably on bare metal if required on the same infrastructure. So this is one of the reference architecture and the validation I wanted to just highlight. Again, this is a SQL 2019 big data cluster, which was actually deployed with PowerFlex. And then also the Kubernetes containers were used with VMware Hypervisor. As I mentioned, there are specific use cases, and then there are a lot of advantages of using containers with VMware Hypervisor, wherein in this solution, we were able to easily isolate and then also make sure that there are some security aspects are taken care for those containers while deploying this on the VMs. So for this, again, this architecture, as you can see, this was started, again, this was like a 4-node PowerFlex configuration, wherein the entire, the big data cluster configuration, whether it is the compute pool and the data pool, everything was configured as containers. And then again, the entire containers were running on VMs on top of VMware vSphere. And then the entire, again, the big data cluster consisted of various data sources like Spark and HDFS, which were used to pull in the data, and then actually the same data was processed through the SQL engine. So this solution, again proved that we can have this kind of a container-based deployment for even like traditional databases like SQL, which is a more effective way of using all the resources. And then also it provides you all the benefits, like, okay, the scale out benefits which you can provide. Again, in this kind of big data cluster deployments, there is always a challenge of data being like growing significantly on a daily basis. So this kind of environments will again help in scaling the environment. And then it's very easy to scale the environment in PowerFlex. As I mentioned, the scalability benefits, you can just add a node, and then automatically the PowerFlex will be doing all the rebalancing and whatever is required at the storage layer in the background. So it provides you the same kind of performance and the scalability benefit. And then again, the SQL big data cluster, again, this is a detailed reference architecture. I'll provide you a link for this solution. Just wanted to highlight that the entire big data cluster environment can be deployed as containers on top of VMs here. And similarly, we did a solution with Oracle, which is one more traditional large enterprise database. Oracle, again, it was done on multiple, again, operating systems and then multiple container platforms. And then also Oracle 12c and 19c, both were used as there are still a lot of customers using 12c, even though 19c has been released. Again, there is a lot of use cases, especially for Oracle, where the customers are looking for test dev and DevOps kind of environment. Again, in this solution validates that, again, this was done with Kubernetes containers running on top of VMware. So the links are the URLs for this detailed solution. Again, whatever I shared there is very brief update on some of the key architecture concepts. But again, these are the links, are the URLs for these two solutions, which will provide you all the details, including sizing, how you deploy, and the reference architecture for these two solutions. One is the SQL 2019 Big Data Cluster on PowerFlex with Kubernetes and VMware, and the other one is the Oracle on Kubernetes with VMware running on PowerFlex. So as I mentioned, in addition to traditional databases, again, NoSQL databases like Cassandra or MongoDB, these are very predominant with containers. Again, PowerFlex as can provide, not only it can support any kind of virtualization or bare metal, and then also it provides support to bare metal configuration and containers. And then it also has all the support required for deployment of containers like CSA support. And then also the benefits which you can get with respect to scalability is really ideal for these kind of NoSQL databases. And then what you're seeing here are some of the solutions which we have validated for cloud native applications like Cassandra on top of PowerFlex with Kubernetes. So just to conclude, whatever is the kind of applications, whether it is traditional databases like SQL Server or Oracle, or whether it is like a modern NoSQL database like Cassandra, or an analytics application like Elasticstack or SAS, PowerFlex can provide you the most predictable and performance-driven outcome for your applications. As you can see, some of the in-house performance numbers here, the number, you can get up to 10 or 11 million or more than that IOPS for any of your applications with kind of sub-millisecond latency. For an application like Oracle, you can get like 10 million IOPS with sub-millisecond latency. And then also for modern applications like Cassandra, you get up to like more than 300, 400K operations. And the key thing I wanted to highlight here is these are all performance numbers which you can expect or get from PowerFlex with sub-millisecond latency.